to the stage.
Good afternoon. It's an honor to be here with you today to share a little bit about UPS and about what we're doing to shift the transportation paradigm. And with that, I've got a video I'm going to share with the group. Gosh, the first time I saw AIAA was back in 2019. We made a visit up to Burlington, and the aircraft, serial number 1 and 2, were still in work. We've hit several milestones with Beta over the last 5 years.
UPS.
Beta Technologies.
Beta Technologies.
UPS is buying 10 from startup Beta Technologies.
And this deal with UPS is clearly a huge deal for Beta, but for the entire industry. It telegraphs the reality of electric vertical takeoff and landing aircraft coming to a massive player in the logistics world.
I'm excited, very excited. Yeah, I mean, I think since my first trip to Beta in 2019, I've been looking forward to the opportunity to finally get in the aircraft and actually fly it. So this is awesome.
Yeah, when I think back to the early days of our relationship with Beta, flying Chase was one of those moments in time where it really made it real. We had the opportunity to see the aircraft flying mission profiles, stalls. Once you see the aircraft in the air, it made it real.
Every time we have a trip up to Burlington to go see Beta, the energy and the culture in there is so exciting that we all come back energized, and so it's great to see the exciting progress that's happening. It's really fun to be part of that.
When we took the next step, it was bringing Beta into Louisville, into Worldport operations. We shared the aircraft with the leadership in Louisville and had the opportunity to have our teams get hands-on with the aircrafts. From there, we did the proof of concept up in Manchester. We consider that our first electric flight on a network route. Although it wasn't carrying revenue volume, we tied it into a nonprofit there in Burlington, and it made it a very special event for us. From the Manchester POC, the next big milestone I think I would chalk up is the transition flight that happened recently. We're super excited to see the eVTOL coming into shape, and then on the back of that, we're out here today for our eval flights with Eric Bergeson operating from our team and getting hands-on with the aircraft.
Beautiful. Beautiful.
One of the challenges to electrifying aviation today is the infrastructure has to be there first. And I don't think there's a lot of other participants that have taken it as serious as Beta. And again, the fact that Beta is putting those charging infrastructure pieces in the ground and in place ahead of the aircraft is very important. Where are we going next? We are working very closely with the Beta team to take an aircraft off the production line to the UAE. The goal is to take that production aircraft to the UAE and get to use it in real world operations.
In the partnership between Beta and UPS, it's been great because we've been able to, we're looking at it through the lens of how we're going to deploy these aircraft, how we're going to use them in active 135 operations. And that's what's been really exciting, is being part of this next leading edge of technology and seeing how it develops.
Our partnership with Beta has been outstanding because the Beta team listens and they react, and they're very innovative.
It's exciting to do things that have never been done before.
Well, again, good afternoon. To kick off, I wanted to open with Jim Sherman, if you know him. He asked me to speak at the event today, and he said the group needs to hear more about the challenges from the industry and the operator perspective. He also said that this is the right group of people to take on those challenges and find solutions. Most people think about UPS primarily as a company with big brown trucks, but there's much more behind the big brown machine, especially as it relates to air and aviation operations. When you think about Louisville, or think about UPS, our corporate headquarters is in Atlanta, but when you think about Louisville, it's the home of all things aviation at UPS. It's where we have our airline headquarters, our global operations center, which is made up of our flight dispatch, maintenance control, crew scheduling, contingency, meteorology, and air network planning functions. The Louisville Muhammad Ali Airport is home to our Worldport All Points hub, and it fills the space between the runways. It's 5.2 million square feet, covers 300 acres, and has parking positions for 125 large jet aircraft. We average 360 daily arrivals and departures there. Louisville is also home to our aircraft maintenance and flight training functions. Now home to Flight Forward as well. To start, I'm going to jump in a little bit with some history. UPS was founded by Jim Casey back in 1907 in Seattle, Washington. It's now one of the world's premier package delivery companies and leading provider of global supply chain management solutions. Over our 117-year history, it's evolved over time, but our founding core principles remain the same, focused on our customers, our people, and innovation. From the beginning, Jim challenged the team to be constructively dissatisfied. That's one of his quotes that I've taken to heart through my 35-year career. And when looking through that lens, we always find opportunities to improve. Our first attempt at air operations, you may not be aware, but it occurred back in 1929. Unfortunately, it was poorly timed with the onset of the Depression. And as that took hold, we had to stop those operations. We didn't return to air service until 1953 and gradually grew our service offerings over time to include our international business. We officially became an airline in 1988 when the FAA approved our 121 Air Carrier Operating Certificate. Today, we have over 500,000 employees. We service 200 countries and territories and operate one of the world's largest airlines. UPS is also one of the largest fleets of alternative fuel vehicles under one global brand. We continue to find ways to disrupt, innovate, and lead the industry. Jim was a visionary and was always thinking about the future. The quote on the screen was from a management conference back in 1954, and I feel it's very relevant for us still here today. He said, "Our horizon is as distant as our mind's eye wishes it to be. Let's get a clear understanding of our objectives, and only then will we be able to map out the highways, skyways, and byways that will take us there." With that, let's fast forward a bit to current day. If you're familiar with our CEO now, Carol Tomei, she's got some quotes of her own. You may have heard, "Better not bigger," and "Sweat the asset." Those are the recent day Jimisms, if you will. Let me jump forward to the next slide. So when we think about innovation at UPS Flight Forward is a relatively new fledgling business. It's a wholly owned subsidiary of UPS. We founded it in 2019 with a small group of subject matter experts from our 121 airline. We established our headquarters, RDT&E function, and training site on the outskirts of Louisville at a place we affectionately call the farm. It's a bit off the grid, but it serves all the purposes we have. These solutions that we're working on are targeted to relieve margin pressure driven by fuel, maintenance, and crew expenses, while also providing alternatives to aging small feeder aircraft fleets. UPS Flight Forward is uniquely positioned to evaluate this technology from multiple views. UPS operates one of the world's largest Part 121 jet airlines, but is also home to an FAA-certified standard Part 135 UAS airline, and the first of its kind. UPS is not an OEM and is not developing in-house aircraft solutions. Instead, we're evaluating the best-in-class and category aircraft to meet specific network needs, safety requirements, and efficiency gains. To date, UPS Flight Forward has evaluated over 850 companies in the industry related to UAS and AAM. UPS Flight Forward is not only charged with advancing UAS and AAM industry solutions, but also protecting the safety and interest of our jet fleet by influencing safe integration of these technologies into our national airspace system. Next, I'd like to share some of our specific milestones that we've accomplished over the last 5 years. As I mentioned, UPS Flight Forward was founded in 2019. We participated at the ask of the FAA, and that started out with the IPP program, Integration Pilot Program, which is now the Beyond program. We earned an industry-first standard Part 135 Air Carrier Certificate and then operated the first revenue flight. All those activities happened in 2019. Since that time, we took the opportunity to take on some additional challenges. With the onset of COVID, we went after our Will Carry Hazmat permit, and we're approved to carry hazmat on our US flights. This unlocked the ability for us to carry COVID-19 vaccines in the U.S. We were also the first operator to have an FAA-accepted SMS and ASAP program, which we believe helped set the bar for the industry, and as you've seen, Part 135 operators will now be required to do so. We were also we had the first revenue BVLOS flight from our remote operations center in Louisville. We accomplished that back in November, and it was an exciting day for us as we were piloting our daily operations in North Carolina from our headquarters facility in Louisville. A big step for us and an unlock we needed for the industry. From there, we've gone to participate in the the IPA agreement with the FAA, Integration Partnership Agreement. And what we did with this program, when we met with the FAA in DC, we asked that the program have some emphasis on advanced air mobility. With that unlock, and that included in the program, we're focused on real-world proof of concept operations as we wait for type-certified aircraft. Next, I'm going to talk about some of the foundational things that we believe needed to happen to unlock the next steps for the industry. UPS Flight Forward is focused on these foundational unlocks to create safe, reliable, scalable, and economically viable UAS and AAM solutions for our global network. Beyond visual line of sight, I just mentioned, is a big step for us. It starts to take visual observers out of those small UAS operations, making them more economically viable. We used a ground-based radar system to maintain airspace awareness for our crew, the remote piloted crew. It eliminates those requirements to have visual observers on the ground. Along with that, we stood up our remote operations center. It's a centralized location using technology to allow one pilot to operate uncrewed aircraft across multiple networks. For us, that has a lot of unlocks. As you start thinking about what we do today with crewed aircraft, the pilots are tied to those physical assets where they are. With this, we have flexibility to have the pilots centralized, work shifts, and then operate the fleet from there. We've got other critical dependencies that we have to address as well. FAA regulations, community engagement and acceptance, and alignment of UAS mission capabilities. And don't forget infrastructure, that's a tough one. As we get beyond that foundation, we've got to evolve. And with that evolution, UPS Flight Forward will focus on unlocks to create that safe, reliable, scalable, economically viable solutions for our delivery networks. One of the ways we plan to do that is in our feeder aircraft fleet. It's currently challenged by several factors, requiring alignment of regulations, technology, to accelerate cost savings and leverage UAS and advanced air mobility capabilities. When you look at the current situation we're in, the FAA requested that we participate in the rulemaking process. We were seeing margin pressure in the industry due to a variety of factors, including aging aircraft, pilot shortages, and cost of fuel. We also, as a company, have sustainability goals that are becoming more relevant. So all of those situations kind of led us to push this concept forward. We've got some complications to deal with as well. There's been production delays. Most of you that monitor the eVTOL industry have seen about a 2-year shift in into-service timelines. FAA type certification has taken time, and with the introduction of powered lift rules, that's also become a challenge for us. NAS integration, infrastructure, and funding are all items of complication. Funding specifically, as the VC funds have dried up, we're seeing more and more of the industry shift to DoD effort projects to get funding, which is slowing down the commercial side. So the path forward, collaboration with industry. We plan to work very closely with industry partners to move forward. We want to inform product requirements. That's one of the most important things I want to share today with this audience is the need to understand what the users require from a ConOps perspective and how we will actually use these assets so they're successful in our network. We want to inform rulemaking and participate in proof of concept operations. In general, we want to advance the capabilities and seek our customer feedback. On to the revolution. So this is where we as an industry come together and build on a solid foundation being put in place. We must evolve economically viable solutions that make operational sense and lead to revolutionary changes to future air networks. This chart, as you can see, has several strategic values we've aligned to those key unlocks. Some of them we've talked about. From the regulatory side, us participating in that regulatory process to influence the adoption of new rulemaking and certifications that allow the advanced air mobility industry to move forward on pace with advances in technology. It's always a pacing issue there. Are the regulations ready and is the technology ready? We want to see them all come to play at the same time. UPS Flight Forward actively participates in the FAA Beyond program and now the Integration Partnership Agreement program. And the FAA established rulemaking ARC committees as well. Public acceptance is also one of those things that needs to be addressed in lockstep as we work through these challenges. So let's move on to autonomy and remote piloting capabilities. The regulatory path to certify and operate advanced air mobility aircraft that leverage autonomous, remotely piloted solutions, we believe will start with the cargo industry first, on small feeder aircraft specifically. And we think that will become the foundation for larger aircraft solutions to come. The approach will layer detect and avoid, sense and avoid, C2 and UTM capabilities to enhance safety, expand piloting to 1-to-many ratio, and these advances are critical unlocks to increasing the utilization of aircraft. In my opinion, this will be the key to scalable solutions. So when you think about, like I said, operations today, you've got pilot tied to aircraft. As those pilots go into required rest, those assets become landlocked, and that's a challenge that we need to get beyond. In our business, we typically fly our aircraft 1 rotation a day for our next day volume. A certain portion of the fleet will fly a 2-day rotation as well, but they're very lightly used assets. Future state for these advanced air mobility aircraft to work, we as an industry have to figure out ways to increase that utilization, and being able to remotely pilot them we think is one of those unlocks. Sustainability. The introduction of alternatively powered AAM solutions that reduced operating cost and carbon footprint while creating innovations will contribute to solutions for larger aircraft. Currently, our UPS large jet aircraft fleet produces 60% of our global carbon footprint. So when we put that in perspective, all the initiatives that we're doing on the ground side still can't overcome that total that we're going after. So we need new solutions to unlock for that jet fleet. Those new solutions that we're looking at today will apply first to those feeder aircraft. We're looking at hydrogen, electric, and hydrogen, hybrid electric and hydrogen solutions, each with their unique benefits and challenges. AAM solutions. So when we think about advanced air mobility aircraft, we tend to lump a lot of it together. We think about autonomy, eVTOL capabilities, blended wing, lighter than air aircraft, and sustainable power plant capabilities. AAM solutions that allow eVTOL direct point-to-point movements are an example of an industry disruptor and game-changing network alternative. No longer tied only to airports for air movements, allowing dynamic point-to-point solutions that reduce time, ground movement segments, and package handles. In our operations today, many times our jets will leave our hub in Louisville. They'll fly to a regional jet gateway. If the volume can make it to its destination on time, that volume will move on the ground. If it can't make that time commitment, that's where our feeder aircraft come in. So think Raleigh-Durham to the Outer Banks. In that example, we leverage a feeder aircraft to take that volume to that last stop at a GA airport on the Outer Banks. From that point, the volume has to be unloaded again off that aircraft, put on a truck, and driven to our center. In future state, if we can take an eVTOL directly from the jet aircraft to our operations center, we save time, money, and resources. So that's one example of how we plan to use the technology. Infrastructure is a big problem for advanced air mobility to move forward, especially eVTOLs and electric aircraft. Refined vertiport guidance is needed that prove industry achievable targets and requirements. We're familiar with engineering briefing 105, but that vertiport design provided initial guidance. We hope to see it updated soon. We hope the updated brief could reduce uncertainty and provide actionable guidance for the industry. Alternative fuel infrastructure and supply chain planning require lead time considerations and must be put in place to support alternative fuel solutions for aircraft, hybrid electric and hydrogen-powered aircraft. We acknowledge and recognize the significance of infrastructure being in place to enable advanced air mobility aircraft to come to market. For us, we're working closely with Beta. They're looking to outfit airports across the United States, and we're trying to align some of their deployment with unique locations that meet our network needs. But you've heard the saying, build it and they will come. This is a build it or they can't. We have to have this infrastructure in place first for the aircraft to come to market. We also need improved NEPA review process. It must be a higher priority item. We've seen these reviews take over a year, even for projects with small footprints. And then on to software solutions. Software solutions that support new network modeling and analysis tools that account for new technologies in aircraft. We're looking at things for robust C2, remote operations center capabilities, and uncrewed traffic management to integrate into the NAS. So when we think about all these things tied together, we think about all these things tied together and moving forward, we have to focus on solutions that provide improved service for our customers, reduce cost, and support sustainability goals. Where are we going next? The FAA Reauthorization Act regulations are beginning to roll out, which we think is a big bonus for the industry and a move forward. Infrastructure is critically important for us. Aircraft type certification, aircraft production certification, and training. The video you saw at the beginning was just a couple weeks ago up in Springfield, Ohio. We shot that in conjunction with one of our pilots flying the AIAA aircraft for the first time, the Beta AIAA. We took some learnings from that, but the process was really intended to put some of our pilots through their training, fly the aircraft, and understand where the state of that process is, and then inform future training needs for us as we plan to take on the eVTOL version of the aircraft. Aircraft into service. People ask us a lot about what our plan is with that into service, especially for the AIAA. Early days when we signed that contract with Beta, our intent was to have a remotely piloted aircraft. We know that was a big ask, and so in the contract we wrote the capabilities to add that when the approvals would allow. So we'll plan to start out piloted operations to start with the Beta aircraft, and then transition to remotely piloted as the regulatory environment allows. And then ultimately, NAS integration. We need a path to remotely piloted aircraft. The industry has pilot shortages that we've seen ebb and flow, but with COVID, when COVID onset happened, we saw a combination of things culminate, really. New pilots weren't entering into the industry. We saw a drawback, which created furloughs. And then when that training bubble came back, it's created a ripple effect. Our 121 airline doesn't really have those problems. We've got a line pretty much out the door to hire pilots. But our Part 135 operators that operate those regional air mobility type missions, those are the areas that we're finding difficulty in keeping those staffed. It's driving the prices of those operations up, and that's one of the reasons we need these type solutions. So as I wrap up, I'd like to challenge you all to think about the advice of Jim Casey and to be constructively dissatisfied. Understand the objectives and imagine that next horizon that's on the way. And with that, I'm going to transition to Julie. She's going to come up and she's going to lead us through the next portion of the schedule. Thank you.
Ladies and gentlemen, please welcome Aviation Guiding Coalition member, Miss Julie Brightwell, 767 project engineer at Boeing Commercial Airplanes, to the stage.
All right, welcome everybody, and thank you so much, Jeff. As the 767 chief engineer, the UPS mission is near and dear to my heart. And I've been particularly excited for this year's conference theme because as an engineer by both profession and to my very core, nothing gets me more excited than the idea that all these amazing dreams and wild concepts that we're talking about that we're seeing out there, that we're looking at the idea of seeing them become reality, seeing us overcome the challenges to make them actually become real, turning those dreams into reality. And like Jeff mentioned, the cargo space is a place where we can really explore making that happen. It's a really good opportunity to do that. So we've got a really great panel lined up here today to help us explore what the future of cargo transportation can really look like. I'm going to give you a super quick intro to these folks on the panel. You can see a lot deeper of their bio on the app. First up, we've got Al Weston. I need my glasses here. Dr. Weston has had a distinguished career across many sectors of the aerospace industry and is currently leading the design and development of a 21st century airship as the CEO of LTA Research. Next up, we have Bill Peterson. He's the CEO of Flying Ship. He's renowned for his groundbreaking work in creating unmanned wing-in-ground effect transportation craft that will bring aviation speeds to the maritime sector. And finally, we have Dan Newman, who's the Chief Technology Officer for Honeywell Advanced Air Mobility. He's responsible for planning and executing the technology roadmap for product offerings and aligning with Honeywell's advanced technology development and macro trends, including autonomy and AI. So without further ado, let me turn it over to the panel to hear about how we're shifting the cargo transformation paradigm. Wow.
I'm going to show the notes. Thank you, Julie, for your kind introduction. And thank you to the AIAA, to Jim Sherman and Dan Dunbacher for inviting LTA Research back to the annual Aviation Forum again. And thank you for inviting me to attend and be part of this distinguished panel. It's a great honor. I'd like to start off by thanking everybody at LTA for the really hard work over the last 10 years. It's been quite the adventure, quite the journey. But remember, LTA, the best is yet to come. I'd also like to say thank you to our partners around the world. In particular, I'd like to call out Zeppelin, who's been with us from the beginning, and HR Textron Pipistrel, who's provided a fantastic electric propulsion system to us. And a shout out to the larger AAM community that is making such great progress. LTA airships are going to reduce the carbon footprint of air cargo and speed up the delivery of humanitarian aid after a natural disaster by being able to reach remote locations with little or no infrastructure. It's a bold mission, and I'm proud to be part of it. Airships are unique. They can perform vertical takeoff and landing, and they can hover quietly. They are the most efficient form of aviation because they don't use energy to create lift. They can and have flown around the world, and they can carry and have carried very large payloads. Airships can fill the capability gap in between aircraft and surface transport that use sea vehicles and ground-based vehicles. Airships can have a lower cost per ton mile or ton kilometer than trucks. They can carry mid-size freight and also cargo freight for projects. They can support consumer transport and deliver humanitarian aid. When we look at cargo transport today, you have a choice of going quickly by air or slowly by ground or sea. In any case, or any of these cases, there is a significant infrastructure cost associated with cargo transport, either in airports or in seaports, in railways or highways. Airships don't need these. When we look at what we want airships to do for the cargo market, we see short-range missions for congested urban needs like San Diego to LA or DC to New York, for example. We also see a range of cargo needs from 2 tons to 150 tons. Larger airships will have lower costs per ton mile or ton kilometer. A challenge that you're going to hear from me today, as you already have heard from Jeff, is a question of affordability. So one question is, if airships are so great, where are they? When I started this project 10 years ago, a constant theme of people that I met was, are you crazy? It's going to be much too hard to do this. It's going to take too much time, and it's going to cost too much money. So LTA is challenging those assumptions. We believe that airships can be built, can be designed and built and operated affordably. This is a key to reach and to access a very large market. Speaking of affordability, since the beginning of this project, we have put a huge amount of effort into the design and manufacturing and operations that will reduce cost. Back in the day, when the Akron was built, it took over 1,000 people 3 years in 1929 to 1932 to build the first very large Goodyear airship, rigid airship in Ohio. So we've put a lot of thought into designs and manufacturing methods that will change that completely. And here is one example, which we call the roller coaster. It's one of many examples, but it's a really important beginning. So here we see that the airship is rolling around, and it allows us to build out the structure in between the mainframes, which are like the ribs of the whale. Here we're demonstrating that we can build 2 sections of the airship at once. In the future, we're going to connect all of these mainframes at the same time, which will allow us to build the entire airframe in 1 week. LTA has built the first rigid airship of its kind in 86 years since the LZ-130, the Graf Zeppelin II. It's also the biggest aircraft in the world today, and it's the biggest airship in length since the Graf Zeppelin II. It's the world's first manned electric airship, and it's got 12 propulsion units that are thrust-vectored using electric motors on pylons. We are in a flight test program at Moffett Field, and we expect to be flying over the bay very soon. Pathfinder 1 is a technology demonstration project which is validating our approaches to design, manufacturing, and operations. And here is a recent flight test. We have done a lot of flight tests over the last year. We tend to fly early in the morning. Here's dawn is breaking. We do it early in the morning to minimize the amount of wind that we have to experience when we go in and out of the hangar. With airships, bigger is better. Why is that? It's because the drag goes as the surface area, but the lift is proportional to the volume. Hence the so-called square cube law. If you look at this picture, you see that we've looked at 3 airships, from Pathfinder 1 to Pathfinder 3 to what we call the Big Bird, which is 300 meters long. Our Big Bird is 2.5 times more fuel efficient to transfer cargo than the Pathfinder 1, as an example. For the airship industry to be successful, we have to scale up. Can we scale up? Yes, we can. And here I'm going to show you our signature hull design and manufacturing method where we've scaled up a 20-meter diameter airship to a 30-meter diameter. This is being done in the air dock, the LTA air dock in Akron, Ohio, the home of the Goodyear airships from the 30s. When we think about airships, in the past, they were limited to about 70 to 75, I think one of them got up to 80 knots in terms of their top speed, and they cruised at slower speeds. Can airships go faster? Absolutely they can, but there's a cost. There's a cost in terms of fuel weight. Today, conventional hybrid electric airships are really good, but the cost of fuel for going high speed is great. And you end up with a very significant weight penalty if you start flying quicker, which costs in cargo. The answer to this dilemma is to use hydrogen fuel. Why? Because hydrogen is a lot more energetic, and hydrogen fuel cells are a lot more fuel efficient. The result of this, when you put these two together, is you use 4 times less fuel weight to achieve the same speed, and you still retain significant cargo when you're going faster. While conventional hybrid electric airships are really good and reduce the carbon footprint of aviation a lot, I see the future for aviation in general using hydrogen fuel. And so we've been studying hydrogen now for 7 years. And it turns out that the research that's been going on and being flight tested today that uses hydrogen fuel cells as opposed to burning hydrogen gas turbines is a really good match for airships. Partly because airships are really big. But hydrogen-powered airships can also go faster, carry more cargo, and eventually be cheaper as the cost of hydrogen goes down. And so, in conclusion, it's a big deal. Hydrogen-powered airships will be faster, better, cheaper, and greener. When I look at the challenges for the future, the first one, as I've said before, is scaling up. And while we're making progress as a community, there's more work to be done. The second area is in the powertrain. And again, while we can build conventional hybrid electric powertrains today with certified components, I see the future for aviation in general being hydrogen. The big challenge with hydrogen is being able to store it as a liquid. And while aluminum hydrogen tanks that carry liquid hydrogen have been built today, the key for the future for both aircraft and airships are carbon fiber liquid hydrogen tanks, which are being developed today. Fuel cells are being flight tested today at the 1 megawatt level, but larger fuel cells are needed for both aircraft and airships, and they are also being developed today, but they remain an unproven challenge. The last issue for powertrains is thermal management, and again, this is something for aircraft and airships. But fortunately, with liquid hydrogen and hydrogen fuel cells, you can use the liquid hydrogen to cool the liquid hydrogen, the exhaust gas from the hydrogen fuel cell, which happens to be water, which in the case of airships, you can actually use. The third area for cargo airships that needs to be worked is certification. The FAA was created in 1958, 20 years after the last great airship was built. No large airship has been built and certified since. There have been really great efforts by industry and government agencies around the world to draft the regulations, but none of them have been tested through the use of design, manufacturing, build, and operations yet. At the same time, hydrogen powertrains, which I see as the future, are also going through the certification process. Looking to the future looks great. There are lots of positive trends that will support the introduction of cargo airships, that will reduce the carbon footprint of aviation and deliver humanitarian relief. The current trends are faster research and development through certification, dramatic improvements in materials and manufacturing, and the development of hydrogen power for aviation. I see the current trends leading to the mass deployment of large airships. Thank you, everybody. And as they say in the Light to the Air community, up ship!
That was absolutely fascinating. That's a very cool technology. Let's see if this jumps over to my slides.
Nope. There we go.
There we go. Perfect. Thank you, everybody. So I'm Bill Peterson, founder and CEO of Flying Ship Technologies Corporation. We have more than $200 million worth of commercial customer commitments and a range of activities happening across the DoD for a new type of vehicle that is transforming global logistics. We've been hearing all about all of the challenges faced in the aviation and transportation markets. Here are just a few of them, just to give a quick recap. Gridlock at points at fixed infrastructure, very restrictive regulations, expensive overnight transportation for cargo and freight, and lots of pollution. And these outdated solutions that are currently being used are just not going to fix these problems or deal with the ramp up that is faced by the end customer. Also on the military side, we're seeing China rapidly accelerating their technology all across the Indo-PACOM. We've got aging fleets, and there's a need to keep troops outside of the weapons engagement zone. And again, these older legacy technologies and this slow certification process are not going to help us meet the current demand, which is why we have created unmanned ground effect vessels that are classified as maritime vessels, just like hovercraft, because they do not leave this dynamic cushion of air that is sandwiched between the wing and the ground. Here's one of our prototypes in action, and because they're classified as maritime vessels and not aircraft, you have many regulatory advantages that we were just discussing in the back room. Also, this cushion of air increases lift, decreases drag, so you have operational advantages as well. So at a high level, you take a look at this technology, and these are craft that can be 10 times faster than anything on the ocean, less than a quarter of the operating cost of comparable aircraft. It's green technology and provides countless numbers of additional access points to coastal regions for logistics. Just a quick summary of the craft in itself. Where we're taking this technology is to eventually be able to take thousands of pounds of payload to anywhere with a coastline using AI navigation systems, hybrid electric and electric power trans. And the military folks like this because it literally flies underneath the radar and it's above sonar, so it's hard to detect. This gives a high-level summary, again, touching on some of it really aligns very nicely with some of the things that Jeff was talking about. Not only because it's a maritime vessel and all of the systems on board are classified as maritime or do not have to go through the AS9100 certification process and all of the other aviation processes that increase cost. So purchase price is lower, the maintenance and sustainment price is lower. Again, using that ground effect air cushion, we could extend the range over a traditional fixed wing aircraft, so lower energy cost per mile. By removing the pilot from the craft, not only do you not have to have seats, but you don't have to have a cockpit, you don't have to have windows, you don't have to have HVAC or any of the systems traditionally that take up weight and space. So we remove that, giving the craft itself greater asset utilization, but we also have higher uptime than traditional fixed wing aircraft as well. So multiple efficiencies over a traditional aircraft. Looking at the urban air mobility market and the technology, I do not want to seem like I'm hating on that market because I love the technology that's coming out. I'm a big fan of it, but just looking at the snapshot, again, quarter of the operating costs of those AAM platforms save literally, and this is probably a very conservative estimate, $150 million in the certification process, being able to save that, and dramatically reducing the time to certify the craft itself. And when you optimize for ground effect and take out all of the human-rated systems, you've got about a 50% energy efficiency gain over the traditional fixed-wing aircraft. Again, this is some of this is a bit redundant, but looking at some of the other platforms. Now, wing and ground effect is not new. In fact, the Wright brothers, Orville and Wilbur Wright, didn't get out of ground effect when they were operating their craft. And then, of course, the Russians famously built the Caspian Sea monster, chronoplans, that many of us aviation geeks have known all about. And there are a few other companies. This is the second image down there is a picture of a Singaporean company that is, but most of the companies right now are doing human-rated ground effect craft that are, piloted people movers, and they're limited to ports. There's another challenge that they're going to face that we are not going to face, and that is that when you're trying to move at several hundred miles an hour just over the ocean and you want to use a ship captain rather than an aircraft pilot, there may be some safety issues that they're going to have to address. So I think that they're juggling that right now, and they may have to use traditional airline pilots. Now, some of the other limitations that aerial drones have, typically they've got a limited range, especially the VTOLs, and again they run into those very restrictive aviation regulations, looking at the final category that I've got down here in terms of maritime freight, it's inexpensive but very slow, and there's a lot of port congestion, and it's very pollutive. So there really aren't too many options for that time-critical, price-sensitive delivery that is needed. Sorry, Jeff, I didn't ask if I could put your logo up here, but it's a massive market. Now, this straddles a couple of different verticals. Of course, it's sort of a blue ocean type of a system, but it meets the needs of traditional air freight companies and maritime freight companies, and also government. Our government and NATO governments have a lot of interest in this type of technology for not just transportation, but some other things as well. I put a couple of case studies. This is sort of an eye chart, and I apologize, guys. But one of our current customers that has signed up is looking at being able to move transportation or transport freight across the Caribbean. When you look at some of these islands, many of the larger islands, they have no issue getting freight. In fact, Jeff, I'm sure has much more expertise than I do in that realm. But when you look at the smaller islands that either have very small runways or don't have runways, a gallon of milk can cost up to $30. And they don't make anything on many of these islands, or they make very little on these islands. So by being able to provide better logistics to just the Caribbean, you can improve the lives of hundreds of thousands, if not millions of people living in some of these regions by lowering the cost of time-sensitive, price-critical goods like food, medicine, retail, some of the things that we just take for granted on a day-to-day basis. So that's our target. This is where we're going for first, for these island chains, and also looking up and down coastal regions. But we've got an existing customer base customers that have already signed up in these areas. I've got some examples of military transportation. But looking at the V-22, awesome aircraft, right? But so expensive. When you just run the numbers, we're a 20th the operating cost of a V-22. LCACs are great, but they have limitations as well. So where are we? So we're developing. We've already developed multiple prototypes. We're building a few larger ones now. We're going to be doing some tests and probably publicizing this fall some of our demos and tests that we're doing with the U.S. military. We're scaling this technology up, but the objective is not to stay on this smaller side. We're not looking at doing small package delivery of this, really. It's to really take that delivery van size payload, taking a UPS delivery van size payload up to anywhere with a coastline. That will have a dramatic impact on the technology. So looking at a couple of our larger models, here's a cutaway of the two larger models. So very similar size and capacity to, say, a Cessna Sky Courier and Cessna Caravan. But we can have better range and less than a quarter of the operating cost of those aircraft. And it doesn't have to be that we compete head-to-head because we cannot land on runways. We don't have landing gear. We do have the ability to pull up to beachheads, but for the most part, we're making deliveries to ramps and to docks using traditional cargo systems. This is not the sexiest of pictures, but it gives you an example of what we're doing on the inside. Kind of cliche to say, but we've got really a world-class team behind this, supporting this. I myself am an aerospace engineer with MBA. Spent my career developing supply chains with some of the world's largest aerospace companies, but we've got folks in here from Lockheed, Boeing, Raytheon, Northrop, the Navy, and others to support this effort. Just here's some of our strategic partners and customers that have signed up. More than 50 successful prototype flights. We've got more patents coming down the pike. Lots of activity across the Department of Defense. Virginia is giving us some state grants to enhance the aerodynamics and to support the technology development. And then a partnership with CMA CGM, who is one of the world's largest shipping and logistics company. Not typically a company that we hear a lot in the aviation world, but you might recognize that logo on the top right-hand side. You see that on the side of a lot of the large containers. With that, I've got a video that I'd like to run. If you could play that. And this video will show, it'll show the initial concept, some of our prototyping, and then a little teaser about some of the technology changes that we're making.
As they get off the stage music.
This prototype has more than a 6.5-foot wingspan. It's hard to tell how big it is. Not huge, not small either, though. Big enough to test systems and ensure all of the systems on board that are scalable work. So we've got a LiDAR system underneath the wing for, we call it elevation control, not altitude control. It locks in the elevation above the water so it can ride with waves. And because of this, you just have to worry about direction and speed. It's connected to all the control surfaces. So it operates like kind of like a RC race car or really a boat is what the objective is. There's such a shortage of pilots that we're not trying to draw from that talent pool as well when we can just operate it just like a ship. And this will go into next generation pretty soon, I promise. We're making even more changes than what we see here. Got more distributed electric propulsion on the trailing edge of the wing. We use a power augmented ram takeoff system that ducts air underneath the leading edge of the wing so that we can take off in heavier sea states. Something that was pioneered by the Soviet Union, but we dramatically improved the design and the capability. So that is it. Let me hand it over to Dan.
Thank you. Good afternoon. Thank you for having me here. I'm representing the Advanced Air Mobility Organization within Honeywell, a Tier 1 supplier to the OEMs. Honeywell's last aircraft as an OEM was a trash can-sized micro-air vehicle in approximately 2008 for the Army's Future Combat System. And since Honeywell has made the clear decision to be a supplier to the industry, I'd like to spend a little bit of time talking about the technologies that enable and some of the key technologies that we'll rely on for this transformation for unmanned cargo. Most are parallel to the crewed aircraft, large advanced air mobility, the current fleet. Honeywell looks forward to the opportunity to supply. We have content on most of the aircraft developers now. At this point, we envision ourselves as, in some ways, infrastructure, trying to advance the technologies, enable the industry. You'll see in some ways, a significant amount of this is not invention. It's a bit of research and development, but development of the products at scale, at the scale required. Honeywell comes in with a pedigree of large, safe, passenger-carrying commercial aircraft, Airbus, Boeing, Leonardo helicopters. And our opportunity is to rescale. I wouldn't say diminish the assurance level of that equipment, but to bring our core products to these smaller aircraft, more electrified aircraft, lighter, faster, scaling up in terms of rates, and a customer base that's, instead of years to get in place for the buy, more of a transactional opportunity for a significant number of suppliers. So I'll spend a little time. I don't think this is a surprise to anyone over the years. The trend is to move away from fossil fuels, electrification. Honeywell, 4 years ago, established an advanced air mobility organization to supply both urban air mobility and uncrewed aircraft systems and focus. So Honeywell is a products company. We say we provide just about everything on the aircraft from nose to tail except the structure. And so Honeywell is a group of component experts, industry leading. 4 years ago, they established the Advanced Air Mobility Organization to be the portfolio manager to the OEMs, to these developing eVTOLs, unmanned aircrafts, uncrewed aircraft systems. So these trends are happening in aviation. Honeywell has been excited to be a partner with many of our customers and working closely with regulators. Again, tailoring our products and advancing new products for all the areas required for this new field. Our vision is in 3 parts. Same-day delivery anywhere in the world. Very simple, easy to say. It's a big world out there. There's a lot of distance. And as Jeff, as others have said, our challenge is making that affordable and scalable. From a passenger standpoint, it's a 100-mile commute in 45 minutes, again, anywhere in the world. And bringing those technologies to our militaries to preclude conflicts and win when required. As I said, Honeywell, it's simple to say we provide just about everything on the aircraft except the structure nose to tail. It's a little bit of, I'll go into the details here, you don't need to read that writing. But fundamentally, we see it in 2 areas. Integrated avionics systems, the aviate piece, the communicate piece, and the navigate piece of the airplane. We call it stick to surface. Integrated systems, providing those for the uncrewed systems and urban air mobility, and then integrated propulsion. As I said, Honeywell is a group of, an aggregate of a series of companies that provided different components, and our goal in what we call the greenhouse, our urban air mobility greenhouse, uncrewed air systems greenhouse, is to try and integrate those systems, tailor them better to these markets, integrate them, have them talk to each other, take advantage of digitization, smart, and has been said, try and have these aircraft intelligent, whether it's the operation of the aircraft or the need for maintenance of the aircraft, the scheduling of the aircraft. Huge opportunities out there to use technology to our advantage. Rethinking these, and Honeywell hopes to be a partner in making these a reality. Talk a little bit more about integrated avionics, what the pieces are of that system. So it's the vehicle management systems, essentially keep the wings level. Again, aviate, navigate, communicate. It's the connectivity on board the aircraft and the connectivity off the aircraft. The fleet's connected, maintenance connected, prognostics and diagnostics to truly understand what's going on with the aircraft, and ideally turn every unscheduled maintenance action into a scheduled maintenance action. And then talk about the aircraft. I'll talk a little bit more about the navigation and see and avoid. But again, modular architecture, partnering where we can. We're just getting involved in a NATO study on modularity, which is trying to envision how to take systems, not just open systems architecture with avionics and applications, but transition that also to talking about the hardware, having modular hardware, mission-specific hardware. Again, maximizing the capability for common systems, common structure, minimum sustainment costs. Anthem Avionics. So Honeywell is developing for large scale and scaling down into this unmanned air mobility, our Anthem Avionics systems, which brings the capability you're seeing in home computing, developing applications, what's in your smartphone, but in a safe manner, giving our customers the capability to bring applications to their systems, to operate their aircraft and customize their aircraft without bringing in what we call vendor lock. Our military customers, our commercial customers have always had a challenge with the suppliers having huge costs and huge timeline associated with upgrades. The Anthem Avionics brings the capability for our customers to develop their own non-flight critical systems in complete concert with the safe avionics systems. Fly-by-wire, so this is the brains of the system. Expanding that, making it smaller, making it more capable. Unmanned systems won't have the avionics, bringing the vehicle management systems into the fly-by-wire, and then taking those Honeywell pedigree of safe commercial transportation and bringing those same products into a form factor and costs that are compatible with uncrewed systems. So to make sure that we bring that pedigree, but we do the system safety both at the component level and the system level. Again, compact fly-by-wire, you can see the pedigree here, but bringing those to the urban air mobility and then to the uncrewed systems. Alternative navigation, there's challenges here. When you're in complex urban terrain, there's blockage of GPS, there's multipath of GPS, but more importantly, of much more concern, we've got bad actors. We've got spoofing out there. We see it today. We need navigation systems, especially when they're uncrewed, to make sure that we do in fact know where we are, where we're going, and we can do it in a safe manner. So Honeywell's bringing fully layered alternative navigation systems that leverage the global navigation systems, inertial navigation, optical navigation systems, try and give ourselves much more robust and defensive against both natural and bad actors, human bad actors. Detect and avoid. So at some level, the FAA hopes that the aircraft will bring their own capability to detect traffic, increase the density. So the business is where the people are. We're going to need much more dark, not quite dark in the skies, but the capability for these aircraft to take full advantage of the airspace as a resource and operate in a safe manner, planning, communicating their plan, communicating their intent, communicating their status. So when an aircraft is operating in a degraded status, they should be able to transmit that as well so that the aircraft around can operate in a seamless manner and safe manner. Again, traffic detection functionality. We want to understand both the complex terrain, natural threats, other traffic, and sometimes bad actors. Again, bad actors. Our challenge with operators, both onboard crew and off-board crew, is the challenge of the number of pilots going down, aging pilots as we go down from Vietnam operations, as we increase the number of aircraft in the sky. So we're talking about dramatically reducing the training required. You might have heard of the Mosaic rules for operating aircraft, dramatically reducing the challenges, the training required, and allowing the pilots to focus on the most challenging and risky portions of flight, whether they're on board the aircraft or they're a fleet manager, one on many operating a series of uncrewed aircraft. So reducing the challenges, and again, this view is either on board a vertical aerospace, one of our advertised customers who just had a tethered hover flight the other day, and our ground control station I'll get to in a minute. But again, intuitive displays, dramatically reducing the workload, allowing the pilots to focus on the mission tasks. Seamless connectivity, again, that's the onboard situational awareness, as well as blended with the off-board situational awareness. Taking both the common operating environment, all the information we know that's both aboard the aircraft and shared with the community, and then using intelligence, computer intelligence, to identify the relevant portion of that common operating environment. We call it the CROP, and using that to make decisions. And again, our sensors and our communications are used to update that common operating picture. So with the required precision, the required latency, integrity and assurance of the information, so that the decisions whether those decisions are made by a human operator or by the system, that those decisions are made on the best information available. As I mentioned, the ground control station, we're moving toward the capability to operate large number of aircraft, focus on both the fleet, the aircraft status, the environment, and contingency management, understanding the situation, being able to focus workload and attention on the most significant challenges. You can see here 3 different screens. You're doing the vehicle management when required, when it's not being done with automation, trusted automation. The navigation view, mission planning, and those contingencies. And then the far right is the fleet management, trying to give, at this point, it's the uncrewed aircraft fleet and observing the crewed aircraft fleet as we move toward reduced manning, trying to simplify vehicle operations, moving toward single pilot operations, and perhaps eventually trusted uncrewed operations with passengers. But as we all know, that's metered by our capability, our technology, and the rate at which we can develop a trusted capability. Honeywell also working in terms of actuation, electrifying our aircraft, different scale, jam-proof, high bandwidth actuators with adequate thermal management. There's a lot of challenges there. It's easy to say and hard to do. And so Honeywell's trying to work on all those risks associated with, the holy grail is on-rotor, high bandwidth, fully electric, jam-proof operation. And again, these are our goals, trying to meet our customer needs. Moving to the propulsion side, power plant, power transmission, both the power generation, power transmission, and then the use of that power in an efficient, affordable, fault-tolerant manner with adequate thermal management. There's a lot of caveats in that sentence, and trying to do those all at once is a challenge. Again, easy to say. We're trying to make sure we can do this with the assurance and the integrity. Generators were not part of the reliable, trustworthy portion of flight-critical hardware in aircraft, and now we're trying to move toward, again, fault-tolerant, trusted, safe, high-reliability components for our customers. Vapor cycle cooling, Honeywell expertise, thermal management. It's easy to say, but as we get rid of these emissions, we've actually lost one of the most valuable methods for thermal management because we're not ejecting hot fluids off the aircraft. And so really closing that loop on a system, not just demonstrating we can do it in a lab, but doing it at scale, not just a transient, but steady state with the type of capability and efficiency that's required, bringing to bear all these technologies at the scale required. Motors and inverters, again, the reliability, the fault tolerance, doing it, thermal management, trading between closed cycle fluids, fluid cooling, air cooling, weight, performance, and capability to handle, be cognizant of, and handle contingencies and failures. These bite us. These are the things that are too many words for most of the advertisements and quick statements out there. But getting that engineering done, that's not invention. That's really just the spade work to prove that we can make these systems at scale efficiently and affordably, always fighting weight. Honeywell has content on just about every platform out there. Our goal is to help all, raise all boats. We've got different content. Some are avionics, some are cooling, some are actuation, some are a little bit of each. Our goal is to satisfy our customers, bring this pedigree of trusted capability, advance these. We're working very closely with the regulators. There are still a significant number of challenges out there. As was mentioned, the revenue coming from commercial market is not yet there. There are some countries, some areas of the world where we're going to have early operations. We're really excited about that. But scaling up across all these regulatory agencies and nations, there's still a lot of work to do. And we are working hard to bring to light the challenges, share, and partner with everyone we can. We invite all those who want to participate to engage. Deer Valley outside of Phoenix. We've got huge engineering footprint in Brno in the Czech Republic, in Bangalore and Hyderabad in India, in the United States, very cognizant of export rules, trying to make sure that we bring solutions. We invite you all to partner with us to address these challenges because we're all excited for what we can enable. My last chart, a lot of bullet items. These are the charts I didn't bring, but these are still significant number of technical challenges we need to address. Airspace, traffic management, we talked about that. Cargo, infrastructure, terminals, everything off the aircraft. Honeywell Aerospace Technologies is only 1/4 of Honeywell. There's another organization called Building Automation with huge support services and products in the airport industry on the ground side. Honeywell's beginning to work with our buildings automation organization to understand what we can do where the ground side and the air side meet for runway independent aircraft. Vertiports. I think one of the biggest challenges here is establishing vertiports. Not really technically, but from a regulatory standpoint and more importantly from a community acceptance standpoint. I like to say that Alexander Graham Bell's invention didn't have any value until there was a second handset. And the value in the telephone network is not in the network, it's in the terminals. And the same thing will be true of this. It's the terminals that add value, that bring value here. And that may be our biggest hurdle, is establishing each one of those. The spade work to get every community on board every time we establish a new terminal. Autonomy, I've talked in the past about we can't deliver autonomy. There isn't a product called autonomy. I can't deliver it if I can't show that I complied with your requirements. We don't deliver autonomy. We deliver trusted automation that you will be confident enough to use without human supervision and use it autonomously. On the aircraft side, on the air side, the ground side, the infrastructure. Sustainability we've talked about. Again, that's power generation, but it's not just on the aircraft. It's everything we do. And we have to consider the entire control volume. You can't just say it's an electric aircraft if you're using dirty hydrogen, if you're using dirty electricity. So we have to look at the entire control volume. And then maturing, the valleys of death. Again, it's very easy to say this stuff is ready. No disrespect intended to those who say they're about to deliver it, but it's really the last 1% of the certification that's required, because none of the rest of it matters until it's safe, until it's proven, until it's trusted, and until we have a capability to deliver it day in and day out and truly add value and convince our customers that our products are the ones that they should be spending their money on. That's probably the biggest challenge with saying, oh, we'll just develop it commercially and then we'll sell it back to the military. Well, the commercial is a very harsh master. They're not going to give you a dime until your product works as they need it and it's a better alternative for them. And so that's why this market has some 2-year delay, at least 2-year delay in the revenue generation, because there's so many things that have to be right and we have to work them all, and look forward to partnering with everybody in terms of identifying those challenges and working on that last 1% of what we need to get there. Thank you.
All right, well, thank you, everybody, and thank you for laying out the really cool images of what we're that close, that 1% away from. So I'm going to ask, I've got a couple of questions I'm going to ask the panel, and then feel free to submit some more questions on the app, and we're going to go over to audience questions after a few minutes. So I'm going to start with a question, and everybody outlined several of the challenges we're facing, from regulatory, from infrastructure, sustainability, technology maturation. I'd like each one of you to start out by talking about the thing that you think is maybe the #1 challenge that we're facing, that we need to overcome to get us across that last step, that last 1%, before all of these visions that you've just outlined become realities. So we'll start with you, Jeff.
Thanks. I guess if I had to pick one thing for me from a UPS perspective, is the type certification and production certifications, because as said, that last 1% can be the make or break. And so we really can't scale until we've got type certified projects completed and an aircraft in our hands. So for us, I'd say that would be the top priority.
Al, what are you thinking?
Well, actually, certification is a big challenge for airships as well, and particularly for us with rigid airships, which have never been certified. It's a challenge in that we're still working with the agencies around the world to establish what are the criteria, and how do you get judged. And so that, to me, is the biggest uncertainty today.
Yeah, for us, I think the world's a little bit different because we're going through a different regulatory regime. So we don't necessarily have regulatory challenges. We don't necessarily have technology challenges because we're using a number of commercial off-the-shelf systems on board. So those are vendor selection challenges that we're able to work through. And we do not have a customer acquisition challenge. I think the biggest challenge for us right now is just production at the moment. And Jeff called this out earlier. It's just the investment market kind of ebbs and flows with the interest rates. So we're waiting for that tide to turn. So that's the biggest challenge we're sifting through at the moment.
So I think our biggest challenge is the thing we're not working yet. I think it's a chain. We need the entire chain, and every link has to be in place. And it's the weakest link that's going to stop us. And we're working really hard on a couple of those links. And I think we have a path, even certification, that there's not a lot of invention and technologies here. It's development and developing them for the application. But I think that we're working really hard on certification, and we're really working hard on a couple things, but I'm not sure. I worry that we haven't thought the problem through fully, and we're going to run into something that'll take a couple years and everything else has to wait because we pull on it. I'm not sure what it is. Now, I did mention community acceptance, and I think that people think of community acceptance as the noise when you fly over and customers willing to get on the aircraft when we carry passengers. I did mention community acceptance, I think, of vertiports is a big challenge because you've seen the school board meetings with masks, how excited people get, and they can stop things in their tracks. And they're going to need a trunk line, electric trunk line to the new vertiport that takes a bond issue, which is a vote. I think that's one of the ones I know about that I believe is challenging, is where we're where and from where we will operate them. But I don't think that's as big as a challenge as those two things we forgot.
The things we haven't thought of.
And I don't know what they are yet.
Yeah.
So I think we really have to war game, maybe you have, Jeff, war game the entire system, do a day in the life, and who haven't we thought about, and ask them what they think.
That's a really good point. So I have another question, Dan, and I'd like to start with you. Somebody mentioned earlier, and I think you touched on this a little bit, about, and I think everybody who's talked on this panel talked about vehicles that are going to operate in airspace fairly low to the ground. And that means the airspace in that 0 to 500, 0 to 1,000 feet is going to be pretty crowded in the future. What does that mean we have to look into? What do we have to think about? And maybe you can touch a little bit on that and some of the things you're looking into as we look forward to that.
Well, so the Air Force and Class A airspace does positive control of aircraft. I know where they are. Pilot is in charge, but ultimately I'm giving them authority and permission to fly. And the Air Force and the Marine Corps and dune buggies and automobiles on the road do procedural control, which is, here's the rules, you have to follow the rules, and if everyone follows the rules, we're good, but no one knows where you are at any given time. And I think we have to resolve whether we want to do positive control or procedural control and where we're going to do that. And I think it will get easier, but right now it's still consensus management, so we haven't come to some firm decisions. There are places like UAE and China where their autocracy allows them to not worry about consensus management. They don't have to worry so much about community acceptance, so they will be piloting things. Will we trust that and just do the same, or will we do a consensus-based development? I think that may be the challenge ahead of us, is getting those decisions made. Over.
All right, Al, I've got a question for you. Are airship operators limited by weather? Can you talk a little bit about that?
Thanks, Julie.
Weather impacts.
That's a great question, and it's something that I hear from time to time. In January of 1957, the Chief of Naval Operations wanted to address that question. And so he tasked 2 airship squadrons to start a continuous patrol 300 miles off the northeast coast of the United States. And it happened to be that from the 14th of January to the 24th of 1957 was the worst weather in 35 years. There was snow, there was hail, there were winds on the surface of 60 knots. And during that period, all commercial aircraft and all military aircraft were grounded. But the airships continued to fly on station through that, staying there, coming back, landing, refueling, and continuing to fly. And so, to me, that kind of puts that question to bed, that no, airships can fly in all weather. But thank you for asking the question.
Wow, that's impressive. Okay, Bill, you touched a little bit on other ventures that attempted to make ground effect crafts in the past. Can you talk a little bit about what happened to those ventures?
Yeah, absolutely. So I think the most famous one that has been picking up a little bit, actually more notoriety lately, is the old Soviet Union chronoplans that they were building back in the 1960s. So Khrushchev used to joke that he had boats that could jump over bridges, and I think the Americans all thought he was sampling a little bit too much of that Russian vodka, until we spotted these aircraft with short, stubby wings sitting in the Caspian Sea with our first spy satellites. So, and we didn't know what they were, so they eventually dubbed them the Caspian Sea Monsters. Now, awesome vehicles. They could move at speeds at about 100, about 350 miles an hour. We don't exactly know. They had a heavier lift capacity than Boeing 747s. Massive craft. Now, some of the challenges they ran into is they were using turbine engines that were ingesting sea spray, and it was corroding the most expensive part of the vehicle, so they'd have to throw those out. Also, they had a Soviet pilot piloting or captaining these craft, trying to move that fast, and if they made a mistake, everybody on board was dead. So we've corrected that problem using active control systems, taking the human being out of the element. We're using electric motors that don't ingest sea spray. We've got modern aerodynamics using CFD, computational fluid dynamics, as you all probably know about, and just the materials themselves are just much more sophisticated. So a number of incremental changes, and then I'd say that the major step change is in the AI navigation systems that we can use and employ on board. So those are just that's how we've gotten beyond this.
Thank you. That brings me to a question that I wanted to ask you, Jeff. And you mentioned in your talk that one of your priorities as you launched this Flight Forward effort is protecting the safety of your Part 121 operating fleet. Can you talk a little bit about how you think about that as you introduce this new operating space and how you're doing that with safety at top of mind? And then if anybody else wants to add on and add how you're thinking about some of your new technologies when Jeff has answered.
Sure. So at UPS, when we decided to make this move about 5 years ago, we decided we wanted to do it in a way that complied with all regulations and took safety first. So we stood up our operations with a Part 135 air carrier certificate. With doing that, we became under all FAA requirements. We started out small. So we've started out with small UAS operations. We have daily operations in North Carolina for the Atrium Health Wake Forest Baptist Hospital campus. And what we did is we took that small UAS operation and gradually created these unlocks that we talked about earlier, adding in BVLOS, remote piloted operation, and then we're working now on one-to-many. And as all those come to play, you know, I think that's where we're cutting our teeth and learning our lessons. The next step function for us is to start bringing some of these technologies into the feeder aircraft fleet. So you mentioned a question earlier about that low altitude flying. And yes, the small UAS will stay down in that low altitude area, but as we get into traditional feeder aircraft, now we're going to get into traditionally crewed airspace. And I think that's where new solutions are going to have to be required to accommodate these technologies, and UTM and a lot of the other components come to play.
Does anybody else want to add any thoughts to that?
I think that was great.
Okay. So maybe a question that adds on to that. Everybody talked at some level about autonomy, either simplified vehicles, remotely piloted, or fully autonomous vehicles. And I'll kind of open it up to anybody who wants to answer this question. What can you tell us about how using these technologies will help introduce more autonomy into, I'll say, the traditional or the passenger aviation space?
Maybe I'll start with that one. With our platform, because it's classified as a maritime craft, we're able to integrate some of the autonomous systems that have not gone through the certification process for the FAA, but may be technologically very mature and might be considered a TRL 9 in a different context and a different market. So we're able to use those, and our hope is that by utilizing some of these systems on our platform, they can then be flight tested and then brought over into the aircraft aviation market. So it actually gives them flight time without giving them true flight time. So that's our objective.
That's really interesting.
I don't know if that answered your question or gave a more confusing answer, but
No, that's an interesting concept.
I think one of the things that comes to mind for me is we believe, and this isn't me, UPS just speaking, but I think the industry believes that cargo will be first. Getting passengers to board uncrewed aircraft is a bit of a stretch right now. I've had the opportunity to fly on a couple autonomous type aircraft, and I was willing to do it, but you know, when you're in the industry, you're willing to do those kind of things. But I think there's some exciting things coming, and I don't think they'll immediately hit the market and start out the way we envision. A lot of our trials will probably early state involve a safety pilot or optional pilot on the aircraft, able to do the same function, but proving that case and building the data that's needed. Gradually, our feeder aircraft fleet, we hope to see introduction of true remotely piloted aircraft. We've been cautioned a lot by the FAA not to use the term autonomous. You know, autonomous brings some things with it, but we want to say we will add autonomy capabilities, and ultimately, even when we get to those farther reaching advanced states of the industry, we still see a place where there's going to be a pilot, someone monitoring the aircraft, what's going on with the ability to interact. So we're really not at a point where we're envisioning that pure autonomy by itself. I think another thing that we have to think about is how these vehicles will interact with the ground once you don't have a crew on board. And that's one of those questions not answered yet. Yeah. I think that we're excited with the proof of concepts that we're doing to start learning what those questions should be and how those interactions will take place when you have an uncrewed aircraft show up on an aircraft ramp that traditionally would have been piloted.
Yeah.
There's interest in the light-of-the-air community in autonomy, particularly for delivering cargo. And there are some elements in the community that see that as a pathway to using hydrogen as a lifting gas. LTA is not pursuing that right now, but we're watching those developments with interest.
Jeff, something you mentioned, and I'd like maybe everybody to touch on this a little bit, is the logistics of the future technology showing up at a ground station with some sort of cargo for loading and unloading and the ground crew interactions. Can you talk a little bit about what we think the future of that looks like with this the future state? And you talked about multiple different technologies, but then everybody who talked about the different vision.
Sure. One of the challenges we see, imagine that remotely piloted aircraft showing up on the ramp. When it arrives, today's world, you've got a pilot that interacts with that ground crew and does a lot of things. So who opens the door? Who knows it's safe to approach? All of those kind of things. And then once you get the aircraft safely on the ground, safely in the blocks, if you will, what happens next? How do you interact with the aircraft? In today's fleets, our 121 airline, we support our crews from our global operations center. We help them with their flight plans, the weather, and all those planning things. The small feeder aircraft fleet's different. The pilots really have a lot of that responsibility with the aircraft, and things as simple as making sure the aircraft's in CG and how it's loaded. Mm-hmm. I think those are all challenges that we're going to have to take into context. Another challenge for us is time. With this new technology, the goal is to improve service and improve efficiency. And we have to be cautious that the solutions aren't complicated enough to where we actually add time or deter from our ultimate goal of, timely servicing our customers.
Yeah. Dan, you...
So here's a hot button of mine, is that when people hear uncrewed, they almost always think of the flight crew.
Yeah.
But 70% of the operating costs are, it's all between landing and takeoff, not between takeoff and landing. And so the maintenance, the ground crew, all those other things are all people that need to be paid, the people that they do great work, but there's a lot of portions of their tasks that don't require high-level thinking and could be automated at some level, and eventually trusted to the point where they might be autonomously done. The FAA is not involved in all of those. They're involved in some of those, but I just think there's a huge number of every human-machine interaction is an opportunity for us to bring automation, to make it easier, to make it smarter, to make it more efficient, and maybe to remove the human at some point because we trust that we can do it without.
Interesting.
So I like to talk about between landing and takeoff is unfortunately ignored.
Bill, I know when we were preparing for this discussion, you mentioned some unique challenges that your vehicle, that Flying Ship, will face with interacting with the ground crew. Is that something you can elaborate on a little bit? Just going into some unique venues, I'll say.
Yeah. So don't remember the exact conversation we were having, but I'll try to answer that. So. We have built it with a roll-on, roll-off capability, so we can go straight up to ports, roll on ports, drop the ramp, and use a forklift to pull the freight directly off. Logistics is always at the forefront, and trying to reduce the amount of touch labor is certainly a challenge. So the places that we're starting with have ramps, row ramps, roll-on, roll-off ramps in the ocean right next to airports, so that freight can come directly off of the aircraft and then be forklifted straight onto one of our craft to help create a distributed logistics network around some of these island chains where, in the past, it was just very limited. They would come into a major airport. It would then be taken off the belly of the aircraft, and then you had just a couple options. One, you could air freight it off using another smaller aircraft if there was a runway, or you would stick the air freight on top of a ship, on top of some kind of barge, and then bring it somewhere, and it could be tied up for several days. Sort of defeating the whole purpose of trying to get it there quickly in the first place. So was that the conversation we were having?
Yeah. Thank you. All right. One topic that we haven't really touched on very much is sustainability. I know each of you mentioned it at some point throughout your discussion, but I'll start with you, Al. Could you elaborate a little bit on how sustainability is driving some of your future vision and the goals we're trying to reach?
Well, sustainability has been a key part of our company since the very beginning. And so we've baselined electric propulsion from the beginning. And while we have a very low carbon footprint with our current approach, we are very excited about how technologies being developed within the aviation community will support a zero carbon footprint in the future. And I talked quite a bit about that. We're very excited about hydrogen, for example. So, and also that there's additional benefits that I didn't go into, but hydrogen generates water, and water can help with buoyancy, but also one of the biggest things in airships in the past that was carrying people around the world was carrying water. And with hydrogen, you can make your own.
It's fascinating. Thank you. Does anybody else want to touch on the subject of sustainability?
You know, we are absolutely focused on eventually going all electric when the technology is there. We're first focused on doing a hybrid electric version because of range, and more importantly, there's just not a lot of infrastructure. So when you look at some of these areas that we're trying to bring cargo to, our customers are telling us, look, there are no plugs right by the water. You know, if that's an entirely different investment proposition, but there is gasoline at all of the ports. So, of course, you need to have a customer-focused approach when you do this. Now, our craft are more energy efficient than traditional fixed-wing aircraft, again, because they glide on that cushion of air that increases lift, it decreases drag. We also don't have to climb up to altitude, which is the most energy costly portion of the flight. We will get there eventually, being able to leverage fully electric technology, but it's not there right now from the technology. It is for shorter ranges, but from an infrastructure standpoint, it's not there. So we'll move when the customers allow us, or when the market allows us to.
So from a Honeywell standpoint, we're much broader than aviation. Aerospace Technologies is one of the 4 major global business enterprises, and one of them is a new one, or rebranded, is called ESS, and moved all of our energy solutions into one organization, and that includes developing new methods of creating sustainable aviation fuel, hydrogen fuel cells, hydrogen generation. So our ESS organization outside of the aviation is working how to generate SAF, alternatives, hydrogen generation, and so on. And then within Aerospace Technologies, the Energy and Power Systems is looking at all of our products being able to use SAF. As a matter of fact, our test organization is on 100% SAF right now. Our internal engine tests, our aircraft tests, our flight test fleet is operating on 50% SAF, which is the maximum allowed right now by the FAA. And so Honeywell itself is moving very quickly, very hard toward that, looking at burning hydrogen in our current turbine engines and then moving to hydrogen fuel cells, flying small hydrogen fuel cells on UAS. So again, it's a huge part of Honeywell, far broader than just the Aerospace Technologies piece. So Honeywell's all in.
Awesome.
From UPS's standpoint, you know, sustainability is extremely important to us. As I mentioned, our large jet fleet makes up 60% of our global carbon footprint. We participate in SAF, and you know, right now the demand or the supply is not there for the demand. And even if it was, a lot of operators would be challenged to use it because it's costly. So hopefully as the supply increases, the cost comes down and that cycle perpetuates itself a bit. But in addition to SAF, we're looking at all options kind of in parallel paths. As mentioned, electric solutions are going to be limited. Battery energy density is increasing at roughly 7 to 8% year over year. We'll take advantage of that in step functions with Beta's project and the AIAA aircraft. We know that the aircraft that we get first won't have the ultimate ranges and payloads that we hope to get to, but that over time, those step functions will happen and we'll get better ranges and better performance. Early state, I think hybrids have a place in the fleets because we can extend ranges and do a lot without having to have the required infrastructure all in place. And then hydrogen, we're looking at hydrogen, and it has an opportunity to supply power for larger aircraft. And I do think, from what I've seen and heard so far, hydrogen could be one of those longer-term solutions for aviation in general. So we're looking at all those options and again, just trying to understand when they're going to come to market and how we participate.
That's really exciting. Okay, I've got one more question of mine, and then we're going to jump over to some of the questions from the audience because they're really starting to pile up. So somebody mentioned this morning the subject of connectivity and airplane connectivity, and the question that they posed was a really cool one, so I want to talk about it. It's not necessarily unique to the subject of cargo, but it does definitely apply to cargo airplanes and then potentially other things beyond just cargo themselves. So the question that they asked was, do the airplanes call home to order their own spare parts? And so I want to pose that question and how you think about connectivity on an airplane or air vehicle, and then how that could specifically apply to the cargo transportation space. So I kind of pose it to anybody who wants to answer.
Look at me. Yeah, I mean, I mentioned it is that we have, as a aircraft conceptual designer, it's always been dollars per pound, payload performance. But we need to put into our multidisciplinary optimizations the whole life cycle cost and spend the time and install on the airplane enough smarts to know what it needs and to advertise ahead of time. And again, it goes to the digitized information, knowing what the airplane needs. And as I said, it's between landing and takeoff where we're going to spend all that time trying to get it. Ideally, I'll just tell a quick story. I went to DARPA and my proposal to the director at DARPA was to have aircraft that could operate 23 hours a day. And I called that concept reset during refuel. In the hour it was on the ground, I wanted it to be able to be reset to factory standards. And that was my proposal to the agency director, and his response was, well, just don't land, let's make it a power beaming program. So he completely missed the whole sustainment piece. But at some level, sustainment versus sustainability and improving the sustainment is perhaps even bigger sustainability improvement than emissions. We focus on emissions, but there's so much on the ground in the sustainment pipeline that we could improve. So I think this communicated and improving the sustainment pipeline could be a bigger sustainability benefit if we really take into account the entire control volume.
Yeah, the idea of keeping the airplane moving, keeping the airplane in the air, and you touched on it a little bit when you were talking, that the time spent on the ground, if you can minimize that, then the airplane is earning more for you. So,
absolutely, utilization's, I think, critically important to this industry to move forward so that it can scale. And I think we'll take advantage of current health management systems on aircraft and hopefully expand that envelope to where we're more predictive about what's coming, potentially not waiting for current day crew to land and write something up to need to start thinking about the fix. In our world also, having parts in the right place at the right time. I think as these systems get smarter and more predictive, we'll know how to supply the network most efficiently. And then hopefully as an industry, we already collaborate with other partners in the industry for parts and sharing as needed. But I think that again could allow for that more predictive approach.
Can only improve. Yeah, that's great. All right, we're going to launch into some of this really long list of questions we've got from the audience. So thank you, everybody, for submitting some really good ones. So I'm going to start with one that's to Al, an LTA that's got a lot of upvotes here. So what lessons have you learned from the cargo lifter failure, and what are you doing differently going forward?
Cargo lifter lessons learned. I have friends who worked on cargo lifter, and so I'm respectful and impressed about the scale of what they attempted to do. to me, the big takeaway was to start a bit smaller, and that's what we've done. In fact, that was one of the things that we decided early on, was to build something that is only 125 meters long, but it's still a lot smaller than cargo lifter, for example. So that to me was really, I think, the biggest takeaway.
All right. Okay, this is a question for Bill, and there's a lot of people that want to know the answer to this. Are there any concerns with high waves in between islands or beyond, and how do you deal with that?
Yeah, absolutely. So just like airships, ground effect craft do better with the larger they are. The more inertia you have, you're never gonna, and just like a small boat or a small aircraft, you're not gonna operate them in every single weather condition. So yes, they are a challenge, and it really, the larger the craft, the heavier sea states you can overcome, and we can scale up to a version that can operate 90% of all global sea states, take off at sea state 3, fly over sea state 5, and land at sea state 4. But yes, just has to be bigger.
All right, this is a question for everybody. How long are the certification cycles for each of the vehicles, and are you leveraging digital engineering in any way to help?
So the certification process is different in the maritime world. It's between 1 and 2 years, and yes, all of the digital, we're using digital twinning and everything else to enhance and speed up the process.
We're not building an aircraft, so I'm not going to speak from an OEM perspective, but have worked with Boeing and lots of companies over time. And on the aviation side, the process can be long. And it's one thing to go through prototyping, but once you have a conformed aircraft, you're still talking typically another year to 2 years once you've locked everything down.
So I'll just say that due to events that have occurred in the recent past, the regulators have lost trust. And in some cases it's warranted, and in some cases it's a little overboard, but trust is easy to lose and hard to recover. And new organizations, the FAA, EASA cannot check every equation, and therefore there's some level of trust by demonstrating you know. And small organizations are very creative and aggressive, but they don't have the history. And so the cycles, especially for new configurations, whether they're maritime or airships, there's some level of trust required. There's also a requirement to validate the models. Even if you're the most trustworthy, high integrity, sincere person, there's a question whether the models are valid in the environments that you intend to operate. And so there's a slog there to get through and get the regulators to trust that you know what you're doing and that you're not taking undue risks. And so new vehicles, new configurations, new footprints, they take time. No amount, doesn't matter how smart you are, there is a level of trust required, and the regulator's primary job is to protect the people and things on the ground who didn't get a vote. Not the people who got on board, but the people over whom you fly. And that's their primary responsibility. And as one of those people, and they fly over my kids, I'm excited that they're conservative. But on the industry side, it's frustrating.
Yeah.
So it's our job to be candid and be clear and be trustworthy so we can be trusted.
And we have this conversation all the time. It's often not even just a matter of trust. With the FAA, they're being obligated to hold the paper up and show to Congress, look, we held the OEM accountable, and prove that we have every T crossed and I dotted. And so it doesn't matter whether they trust you, that you've got to prove it, and you've got to have it all written down. So they're not trying to be unreasonable. Al, do you want to comment?
Yeah, LTA has embraced digital engineering and digital twins from its beginning. We're laser focused on the first of flight testing our first airship, which is an experimental airship. So we're not focused on certification today. We're thinking about what it would look like at some point in the future. It does appear to me, though, that what I hear in industry magazines and in conferences, that this is a bit of a buzzword. As I'm sure that you know, it's been going on for a long, long time. It's not actually brand spanking new. It's been going on for maybe 20, 30 years. It is really important, and we're embracing it and using it every day.
That's true. All right. Next question. The flying ship presentation shows the airframe scaling directly and proportionally up to the regional model. Is that correct and realistic? Can you talk a little more about that?
No, it's not correct. Those are just graphics that we're looking at. So we're redoing the outer mold line right now of 2 of our designs, and it'll look completely different for each. Not completely different. Obviously, we all know that you don't just stretch an aircraft and make it look bigger, but the designs will be different.
All right. Okay, Jeff, you touched on this just a little bit, but I'll ask the question, and if there's anything more you want to add to it, I'll give you the opportunity. For UPS, do you think it's possible to decarbonize your jet fleet to meet net zero goals without increasing your fuel costs?
It's a tough question. I think it's possible. What horizon it's going to take, that's a question. I think there's a lot going on in the industry to make solutions that will lead to that state, but I can't really put a date on when that would happen.
I'll just, to a first order, if you meet a new requirement without any effort, that's awesome. But it's randomly lucky. It's more likely that a new requirement causes you to do something a little different that will sub-optimize what you had before. Because if it would have made it better, you would have done it already. So every new requirement costs you something, and the question is it worth it? And what's it cost you to do it? So our challenge is it heavier so we get less payload? Is it more expensive for the SAF fuel? Is it harder to scale? We don't know yet. But if we want to decarbonize, we'll pay the price. We'll pay the cost. We just have to minimize that cost. Maybe we invent something that reduces the cost, and we can decarbonize and make it lighter and cheaper. That would have been great. Had we thought of it before, we would have done it, even without thinking of decarbonizing. But the necessity is the mother of invention. We cause people to think, we challenge them, and maybe something amazing will come out. So it's all good. We just have to be full cost accounting and not make silly promises, because we also need trust as engineers, not just from the regulators, but from each other.
We just have to think about what is that trade space? What are we looking for? Any other thoughts on that?
I think we're out of time.
All right. I think we're running out of time. Maybe we'll do one last quick question. Trying to look for a really good one to end on. I have one that I didn't get to ask. So you all laid out really different visions for the future. How do those work together to really, this is the buzzword, transform the cargo transportation paradigm?
So we're going to leverage Dan's systems to make huge deliveries by dirigible, and then we're going to use a distributed network along a coastline, and our customer is going to be UPS.
I love it. All right, thank you, everybody.
Great answer.
Thank you. Yeah.
Thank you.